Hello everyone, this is Ashwin here. In this video we are going to see about how to delete an element at the end of the singly linked list. So in this case we have two cases to solve. So let's see that with an example. So case 1. So in the case 1 we have no node or only one node is present. Or so one or no node is present in the linked list. So what we are going to do is I'll just create only one element in the linked list. So I will place an element 3 and this will be the head pointer. So this will be the head pointer. So if there is no element or if there is only one element means that is considered as the end of the linked list. So what we are going to do is we are going to just delete this element. So if we just delete this whole element, we can able to finally update head equals null. So for this case we will just do this single operation and we can able to return the function. And in the next case 2, so it has some elements. So I will just create a linked list of size 4. So here n equals 4. So here we have some elements. So I will say has elements. I will just create a linked list quickly. So I have created 4 nodes. The last node will be pointing to null. And this values will be 5, 3, 1 and 2. I will just connect these nodes. So this is a singly linked list. So we will just connect in single direction. And as usual this will be the head pointer. And I will copy this so we can able to do the operations. So now here we have the elements of 4. So similar to insertion operation, we will just assign this head to temp. So this head will be pointing to temp. I am just creating a copy of the head pointer and I will use this to traverse these elements. So this will be traversed here and after this will be traversed here. And finally we will just reach until the second last element of the linked list. So temp will be here, temp. So what we'll be doing is assigning this particular node pointing to null instead of this particular node. So this node will be negated. So this will be deleted and we'll be updating the operation like. So this next pointer will be pointing to null. That's how we can able to delete the element or node at the end of the linked list. So this is the simple operation. And finally we will return the head pointer because we are not doing any change to the head pointer. We are just changing the second last element of the linked list that will be pointing to null. So this connection also will be broken. And this is how we can able to delete the element at the end of the linked list. So after this the element will be 3 and for this the time complexity is order of n. So the time complexity will be order of n. So this is the worst case time complexity. So what we are doing is we are traversing up to the second last element, right? It is almost equal to the length of the element. That's why in the overall time complexity we are pointing to order of n because of the traversing operation. And after that this is just a constant operation changing the next pointer to null. And yeah, that's it. we have successfully deleted the element at the end of the linked list. So let's see this with the use of algorithm. So as usual, I will just name the parameters. Head is head pointer of linked list, and in the algorithm delete at end. So I'm going to pass the head pointer of the linked list, and we will just deal with the cases. So in the first case, I'll just comment it. So no node or one node is present. So this is our first case. So to check this, if head equals null, or so first it will check for this condition. If this is true means it will directly enter the condition. If this is false means we will check for the next condition, that is only one node. So that will be head.next equals null. So if any of this condition is true means we will assign the head pointer to null automatically. So head equals null, like we have done here. And finally we will return the head pointer. So return head, or else you can also return directly null, because it's actually the null pointer we are returning. So it doesn't matter, you can do it in this way or you can do it the other way also. And we are going to the second case. In the second case, we have to initialize the temporary variable. So initialize temp equals head. Now what we have done is we have traversed up to the second last element of the linked list. So to do that, while temp dot next dot next. So this is temp dot next, and dot next will be pointing to the null value. At that point we will break the loop. So not equals null. So until it satisfies the condition, we will traverse through the linked list. So temp dot next, and finally we have reached the second last element means we will directly assign temp dot next equals null. So temp dot next equals null, that we have done here. And after doing these things, we will return the head pointer. So return head. So this is the whole logic of this algorithm. Now let's recap the algorithm what we have done with these examples. So first we are checking for the first case, if head is null and if head.next is also null means we will assign the head to null pointer and return the head. And in the second case we will initialize the temporary pointer, so that will be pointing to head in the first time, and after that in the loop we will traverse up to the second last element. When the loop breaks, when we have reached the second last element, we will directly assign temp.next equals null. So here temp.next equals null. So using this syntax we have pointed to the null value, so this last element will be deleted. And that's it guys. If you have any queries related to this problem, please leave a comment below. Apart from that, if you like this video, hit the like button and don't forget to subscribe the channel, and see you guys in the next video.